Hello, it is Math with Trig, and I am talking today about amplitude, phase shift, and vertical shift, specifically with sine and cosine. I'm not talking fully about graphing it yet. This is more recognizing it within an equation. I will do another video where I talk about period and frequency, which is actually horizontal stretch and compression. So it takes the wave, the sine or the cosine wave, and either pulls it further apart or smushes it closer together, and I'll talk about that in another video. I can also talk about, I can do a video on special right triangles and unit circles and all that sort of stuff, but I figured I'd start here because this is kind of the basics. Now, I'm not, like I said, starting with the graph, but I am going to start with the idea of the equation. So a normal equation for sine is just y equals sine of x, and for cosine is just y equals cosine of x. You can also do this with tangent. Where I'm teaching right now, I'm not doing tangent, so that's why I'm not going to talk about tangent right now. Tangent is different because it has asymptotes, sine and cosine do not. All right, so if you transform it, what you end up with is, nicely enough, really, really similar to when you do transformations within all other shapes. So if you've done absolute value transformations, quadratic transformations, linear transformations, radical transformations, if you've done any kind of transformations, even with like log and exponential, this fits. If you multiply in front of the equation times a number, what you're doing is you're either making that whole thing bigger, hence the vertical dilation of a stretch. So if I multiply by 2, I'm making it twice as big as it was. Whereas if I multiply by a fraction, I'm making it smaller than it was. So if this is like a 2, like I said, it's going to be twice the size. And so what happens is, normally a sine and a cosine goes from -1 to +1. If you multiply by 2, it's now going to go from -2 to +2. So it stretches it like double what it was. Same thing happens if you do that with cosine. If you do a half, though, what it'll do is it'll take what was from -1 to +1, and it'll half it down to -1/2 to +1/2. Okay? So when you multiply, just like always, it's a dilation. In this case, it's vertical. If it's larger than 1, it's a stretch. If it's between 0 and 1, it's a compression. Phase shift is actually just a fancy word for a translation, and it's a translation that sends you right or left. All right? You do the opposite when you're trapped with your x. So if this is a negative, it actually goes right. If it's a positive, it goes left. Now, one thing I want you to watch out for, and this, I know this threw some of my students off a little bit, we use x for an unknown. We also use theta for an angle unknown. All right, so if it's trapped with its x or its theta, then it is going to do the opposite of what it says it does. So here's our amplitude. Here's our phase shift. And I'm going to do, after this, I'll just do some examples numerically so you can see what I mean. Once you do it, it's like, oh, that's all it is. And it'll be, oh, well, hopefully. I say that, but that's kind of snotty of me. But for most of like my students, once we did it a couple times, it was like, oh, that's all it was. It looks a lot worse than it is once you start pulling the pieces out. All right, vertical shift. Vertical shift is the K. It's on the end of the equation. It is not trapped with the X, so it does exactly what a vertical translation normally does, is it sends you up if it's positive, down if it's negative. We call it a vertical shift because in sine and cosine we have our own language. I blame trigonometry. All right, but what's cool about it is all of these things follow the same rules that we've already seen for other transformations. Okay, so if you multiply, it's amplitude, and it's dilating it, so it's making it either larger or smaller vertically. If you add or subtract to the theta or the x, you're shifting it right or left. If you add or subtract on the end, you're shifting the whole thing up or down. All right, so what I'm going to do is I'm going to do a couple of examples where I just pull out what the amplitude, the phase shift, and the vertical shift are. Once again, this is not going to have graphs to it yet because I think it's easier to deal with the equation first and then start talking about the graphs, because for a lot of students it's confusing to try to figure all of that out while you're also trying to figure out how to graph radians. So, all right, I'm going to erase this. I almost literally stopped and was like, all right, does anybody have any questions, or does anybody need to get a picture of this before I erase it, because that's what I do in my classroom. And there's no one here but my producer and my whistler, so. My oldest has just learned to whistle, and he is whistling constantly now, like without even knowing he's whistling. And I'm sure in his class at school, his teacher is ready for it to be summer. Mr. Whistlepot. Okay. So let's say I have the equation. So I'll do a couple of them. So state amplitude, phase shift, and vertical shift. And what I'm going to do with these also is, after I state them, I'm also going to explain what they do, or like write what they do to the graph. I'm also going to throw in some f of x, just so that you've seen them and you remember f of x just means y.
Hey. Mom, can I go in the video?
I don't need you in the video right now, kiddo.
I'm just going to
Distraction's right. I tell you there's white space in the way.
That's okay. We'll let his hair take up that space. I'm not sure why you think you need to be in the video, but okay, now you need to be quiet. No, well, maybe you can help me, okay? Are you ready? Turn around and look at the board. Okay. All right, I'm going to start with amplitude. Amplitude is a multiplier, and it makes the whole thing bigger. Can you tell in this sentence which one is multiplying?
The X?
Do you think, well, the x has some multiplying happening, but we're looking for a number that's multiplying the whole thing.
3.
Is 3 multiplying? What is 3 doing? It's minusing, isn't it? It's subtracting, so that is not multiplying. So, has to be the 2. All right? What that means is, this is going to stretch my entire graph by 2. So what was at -1 to +1, the size of his face, is now twice his face. Okay? All right. All right, now be quiet, please. Now, the phase shift is really your right and left translation, and it's always trapped with the x or the theta. Oh, look at me. I didn't do any thetas. Shame on me. I really should get in the habit of doing thetas. I think it's a good thing to do when you're doing angles, because it should help you remember that you're in a circular trigonometric layout. Stop. I'm not kidding. Okay. Phase shift. Phase shift is trapped with your x or with your theta. This one is trapped with my x. -3 in the x direction normally sends us left. However, because you're trapped with your x, and you always do the opposite of what your x tells you, because they are not in charge of you anymore. They should, hopefully they never were in charge of you. That would be terrible. All right, but you're going to have a +3 instead, and what this is going to do is this is going to send us right 3. So that was a translation, and this is a dilation. All right, now, this one doesn't have a vertical, so if I were to put the vertical shift, because I did ask for it, you could say it has no vertical shift. None, NA, whatever indicates that there is none. You could put 0, but to me it's almost better to say none, because if you say 0, then it almost seems like there was a number involved, and yes, technically there is an invisible 0 here, but you don't need to put that. Other people might like it that way. I don't know. I'm not the boss of that. I'm just letting you know what I like. All right, next one. All right, are you ready? Now, notice the amplitude in this one was at the start of the sentence. So what do you think my amplitude is in this sentence? Exactly right. It's the one that comes at the start of the sentence. It's a multiplier. If I'm multiplying something by 1/3, do you think I'm making it bigger, or do you think I'm making it smaller? If you have money and I take 1/3 of your money, do you have more money or less money? Less. So this is going to be a compression by 1/3.
Change to my face and shrinks to half.
It shrinks to 1/3 of your face.
Even smaller.
Yep, okay. All right. Shh. Now we'll do our phase shift. Our phase shift is trapped with our theta or our x. There is nothing trapped with our theta. Now, I did this on purpose. I was being tricky. This theta, it has a 4 next to it, but notice they're not joined together like they were up here. That means this is just a regular theta, and this +4 is hanging out on its own. So in this case, we have no phase shift, but we do have a vertical shift. All right, Andrew, what do you think? If I add 4, am I going to go up or down? +4. Mm-hmm. Okay. So this one we had an amplitude and a phase shift. This one we had an amplitude and a vertical shift. And this last one, we're going to get all 3. All right, what's my amplitude, Andrew?
4.
4. What is the 4 going to do?
It's going to multiply.
It's going to multiply. So is it going to make it bigger or smaller? Bigger. Nice. Okay. Now, this one's trapped with its theta. So it's going to do the opposite. So instead of +1, what am I going to have? What's the opposite of +1?
-1.
-1. So that's going to move left 1. Now, this one's not trapped with its theta, so it does exactly what it says it's going to. Is -2 going to send us up or down?
Down.
Perfect. Okay, if my 7-year-old can do this, you can do this. All right, even if you don't know what it means yet in a picture, do you have any idea what this looks like in a picture? No idea. He has no idea. But he can still describe it from the idea that the amplitude is the multiplier. When it's trapped with its theta, or its x, it's the left and right shift. And when it's outside of that, or not trapped, it's the up and down shift. All right? So, that was Sitting Squad. Thank you for the help. That was very nice and helpful of you. All right? Frequency and period is a little bit trickier because it's horizontal. And notice with our horizontal, it does the opposite. So a period and a frequency are going to be a little bit of a trickster. And that's why I'm going to do a separate video on that, because I want you to have the basics first. And next will be period and frequency. All right, thanks. Oh, you can subscribe if you want to. You can like this video if you're into videos. What else could they do? They could comment if they have other things they want me to do videos on. Right?
And they could subscribe.
That's right, they could subscribe. Later.